This is our file that we're writing to, and let's go ahead and take a look at it. Open the file, and this is our log file. What is up, my disciples? Coding Jesus here. If you're new to this channel, my name's Coding Jesus, and if you're old to this channel, as I mentioned in my previous video, my name's also Coding Jesus. Now, if you're on this episode, episode 2, you're probably part of the top 10% of people that were able to make it past episode 1. So you're already on the right path to the location that you want to go to, guys. And this is a trading engine series. It's not going to be done in a week or 2 weeks or 5 weeks. It might not even be done in 10 or 20 weeks, because we're going to be taking this piece by piece to build this up to something that you can be proud of. All right, so what's up? What's in store for us today? In today's video, guys, we're going to be building out a logging facility. Now, why is a logging facility so important? Well, guys, in my previous video, I simply used ILogger. Now, ILogger is great if you want to log things to console. But oftentimes, guys, especially in these performant applications that might have a million different things operating at the same time, you want a persistent log, a log that can either be stored to a database, a file, written down somewhere that you can go back and refer to. So we're going to be building out the logging facility, and in particular implementing a text-based logger that has different log levels. So debug level, trace, debug, information, warning, and error. All right, that's what we're going to do. And guys, if you're new to this video and you haven't watched the previous one, what I like to do is I like to have my setup as such. The right-hand side of my screen is the code that I've already written. I've already written this code before this video because I want to know how to best explain it to you guys before I start recording it. And on the left-hand side, it's where we left off from the last episode. So if you haven't seen the last episode, make sure to catch up so you can know what we'll be starting on today. Alrighty, guys, so let's actually get into it. I will be sharing my screen. And guys, a lot of people in the previous video have emailed me and said, hey, you have your name in the path in which you're saving your source files. And I know that. I mean, all my videos, almost all my videos, I have my name in my video, in my description box, or I mention my name in my video. My name's Tomer. I'm not hiding from anybody or anything. So thanks for, I guess, being concerned, but there's really nothing to be concerned about. Alrighty, guys, so let's go into class. Oh, let me share my screen first. Okay, you can see my screen, but I'm frozen. So I'm going to unfreeze myself. All right, now you can see me. Alrighty, guys, so we are going to go, well, let's first look where we ended off. We ended off here. We ended off at something like this, right? Now we want to add a separate logging facility or a logging library. So we're going to right-click on our solution, go to Add, New Project. We're going to click Class Library, Next, and this is the path in which I save all my source code. I actually have a folder already called LogingCS. So I'm just going to click on this LogingCS here, and that's where we're going to save what's in Common CS. Okay, let's delete Common CS. We don't need that. I'm actually going to save in LogingCS this project. So we're going to start a new project here. We're going to be calling it LogingCS. Alrighty. And it's going to be a .NET Standard 2.1 project. .NET Standard 2.1 is compatible with .NET Core 3.1. Great. Now, guys, let's first start off with the adjustments we need to our csproj file. So let's look at the same adjustments we made to our trading engine csproj file. So let's copy over root namespace. Let's get a language version and assembly name. And we're going to change some of this. So we're here in our LogingCS. Let's go ahead and paste this here. Language version 9. Let's change our root namespace to now logging, because we want our default namespace on every .cs file we create to be logging, and the assembly name will also be logging. Awesome. Now we have to go back here, change the namespace there to logging, and perfect. All right, guys, so what's the goal here? Well, the goal here is to build an extensible logging facility or a logging library where we can create various different types of loggers, a text logger, maybe a console logger, maybe a database logger. And we want to be able to do that in a very modular fashion. So how do we go about doing something like this? Okay, the first thing we need to understand is kind of what our logging interface should look like, how we want to be logging things. Now, when I think about logging things, I think of various levels to log. That's the first thing that comes up to mind. Various levels, and the next thing that comes to mind is what then to log. So when it comes to levels, I think that we have a couple of levels: a debug level, an information level, a warning level, and an error level. Error, of course, being the highest priority. So let's go ahead and create an enumeration that represents different levels of logging priority. So enum, let's call this, what do we want to call this? Log levels? Yeah, log level. Yes. Okay, so we're going to do debug, information, warning, error. Those are our logging levels. Now the next thing we need is an interface to actually go ahead and log. Now when we're thinking of logging in terms of our log levels, we want to be able to call things like log information, log warning, log error. So let's go ahead and add an interface, an ILogger interface here that's going to represent the interface that all our loggers will need to conform to. So interface ILogger. Okie doke. So we're going to go here. It's going to be public, of course, and we are now going to add our various logging methods that will eventually be overridden or implemented rather in our logger. So whether that's a text logger or a database logger. So let's go ahead and let's do debug. And what we're going to take in is a string representing a module. Now this module is where in the code was this called from? Which class was it called from? You'll see that in action in a second. Then the next thing we want is the message. All right, let's do that again. But now I want to have another call to debug. This is going to be an override of debug. But instead of taking in a string message, I want to take an exception. An exception is the base class of any exception. So all exceptions derive from this system.exception class. So it is the least derived object, meaning it can, you can pass in an argument null exception or a invalid operation exception or an argument exception. And this debug will still be able to handle that. All right, why are we getting these squigglies? Method must have, oh yes, our return type. I'm silly. Void return type, right? We don't want to return anything after we log. All right, now let's do our next level here. So let's do information, string module, string message, void information, string module, exception. The next one we'll do warning, string module. The next one we will do, again, a warning, string. Void, last one's error. Exception. Alrighty, this is our interface. This will be our logging interface. Now guys, when it comes to actually differentiating between our log levels here, what are we going to do? Well, we're going to have a class called an abstract logger. And the abstract logger will be responsible for funneling all these methods into one method that will pretty much just do whichever form of logging that you want, whether that is, pushing this log item into a queue, or whether this is pretty much doing whatever. All these methods, they are all going to converge in one abstract method. And that brings us to our next class, which is an abstract logger. So we're going to have another class here called abstract logger. An abstract logger is going to be an abstract class. It's going to inherit from ILogger. Abstract class, and it's going to have it is not only going to implement ILogger's methods, but it's going to have a protected abstract method called log, which will log, which will take in a log level. It'll take in a string module and a string message. Now you'll see what I mean by this in a second, why this is protected and why it's abstract. Let's go ahead and actually show you guys why this is the case. We have all these methods, right? And these all represent a call to a log of a different log level. Now, I don't want to go ahead and implement a given body for each one of these log method calls, because they're pretty much doing the same thing. They're taking in the same parameters, but they're just of a different log level. So what I'm going to do is I'm going to forward these calls to this abstract log method here. And classes that derive from abstract logger can do whatever they want with this log method. They can override it and do whatever they'd like. They have to override it, rather, because it's an abstract method. And they can do whatever they'd like. However they'd like to deal with logging, they can go ahead and do so. Why am I getting this? Abstract is not valid for this item. Method must have a oh, that's why it has no return type. Void, okay. Now let's go ahead and implement these. So I can just right-click, implement. Alrighty, what I'm going to do is I'm just going to forward all these. I'm going to forward the module and the message to this log method, this abstract log method. Now, because we're calling debug here, I know the log level I need to pass over is debug. Now I just forward module and I forward message. All right, I'm going to do the exact same thing for everything. I'm just going to take this, I'm going to copy and paste here. Let's get rid of these spaces in between these calls. Debug, error, information. Oh, we'll get to this in a second. So this is fine, but this is error. Okay, let's move the error stuff to the bottom. I don't want error to be right after debug. That's not the proper order of log level importance here. Of course, error is the most important. We'll keep error at the bottom, and we'll go from the top to the bottom in order of ascending importance. Okay. Now, we want to log the exception. There's two ways to log an exception. I can either call exception.message, which returns a string. This doesn't include the call stack, though, and a call stack is very important when logging an exception. So we're not going to do this. We can do one of two other things to get the entire call stack. We can either do to string, which will generate the entire call stack for us, and it will return a string. Or what we can do is use string interpolation, and pretty much just interpolate this exception as a string. That's what this is doing. And this is pretty much calling to string on the exception in here. That's what this is doing. I like this better. Maybe you don't. It's just my style. So I'm just going to go with this. Alrighty. We can go ahead and copy this and put that here. And this will be info. We will do the same thing here. It will be exception, but this will be information. We'll do the same thing here. This will be warning. We'll go ahead and do the same thing here. And this will be warning. And we'll go ahead, this is error, and then we'll just copy this over and error. Awesome. Okie doke. What are we getting here? Oh. Okay, now we have our abstract logger. Okay, so any class that derives from abstract logger will need to go ahead and override this log method based off its own given implementation. Now let's go ahead and actually implement our TextLogger class. But first, I just like to have constructors for things, even if they're never explicitly called. So this is just going to be public, by the way. And we're going to have a protected constructor because abstract classes should only ever have protected constructors. Awesome. So this is what we have. So before we go ahead and implement, should we do it before or after? Let's do it after. I think it'll be easier to understand if we do it after. First, let's go ahead and define a logger type. So we're going to have a text logger. We can have a database logger. We can have a console logger. So let's generate an enumeration that represents a type of a logger. So new item, class, logger type. Public enumeration. There's going to be a text logger, a database logger, and maybe even a trace logger and a console logger. Now, I'm not going to be implementing these. I'm not implementing database, trace, and console just yet. Okay, I'm only going to be implementing the text logger. It'll be a nice experiment for you guys if you guys can implement the console logger. I think it's actually quite simple to do. Alrighty, so let's go ahead and actually start implementing a text logger. The first thing we need is a text logger interface. So we're going to first have ITextLogger. Now this is where things get interesting. We need to think of the goal that we're trying to achieve here first. Our goal is this. Let's go back to program and let's actually go back to a trading engine server. Right here we have ILogger. We don't want to use ILogger anymore. Why is this giving me an issue? We don't want to use ILogger anymore. All right, what we want to use is we want to use our TextLogger. Now we can't inject a concrete class. We can't inject a TextLogger. We can inject anything that implements ITextLogger. So the goal here is to have ITextLogger and to then move this like this. So we're going to have an instance of ITextLogger, right? So we're going to call this TextLogger. Ba-bam, ba-bam. The first thing we need to do in order to have ITextLogger available to us in our trading engine project file is we need to add a reference to this LogGasync. So LogGasync is part of the solution, but this actual project doesn't reference it yet. So we'll right click on our project, go to add project reference, click there, boom. Now when I do control dot, I can see that the Visual Studio recognizes that we now are able to get this ITextLogger from the trading engine server.logging namespace. So I'm going to do using, and that just pops up right here. Now I have TextLogger available to me. But how do I dependency inject TextLogger? Well, I'd have to go all the way back to my host builder here, and down here I'd have to say services.add-singleton, because this logger will be a singleton available to us everywhere. ITextLogger. And I'll also need the concrete implementation, similar to how we had our iTrading engine, and we had our trading engine server as a concrete implementation of this singleton of this interface. Alrighty, so we have our TextLogger interface. Now our TextLogger interface needs to conform to our ILogger interface, right? Because an ITextLogger is an ILogger. Now what I'm also going to do is I'm also going to make this inherit from iDisposable. Now, iDisposable will be attached to any interface or any class in which you need to free up resources for XYZ reason. Now, I do predict that we will need to free up some resources in the TextLogger class because I've already written the TextLogger on another branch. All right, so we will need to conform to our iDisposable interface because that's what clients of the ITextLogger, or the TextLogger rather, will be calling. They'll be calling dispose on the TextLogger when we want it to be disposed of. Right? The TextLogger is a singleton, so that will be taken care of in the container, the dependency injection container. But if somebody wanted to implement or to call new on a concrete implementation of a TextLogger class, they will need to dispose of it at the end of its use. That's why I'm including this iDisposable here. And we'll take a look at actually implementing iDisposable in a second. Okay, let's create our TextLogger class now. So we're going to have TextLogger. And TextLogger will inherit from both AbstractLogger and ITextLogger. Now we will go ahead and implement the interface of ITextLogger. Now the interface of ITextLogger is ILogger, and it is also iDisposable. So this is the dispose method I will need to implement in a second. We also need to implement everything that TextLogger inherits from AbstractLogger. So let's go ahead and just implement abstract class. Okay. These are the only two things we need to implement. Isn't that easy? You see how easy it is when code is written out nicely and cleanly, and we understand what's going on, and we write clean code? Everything just becomes so much easier for us. Alrighty, now how do we want ITextLogger to work? This is where things get interesting. Well, when I think about a TextLogger, I'm thinking of a couple of things. I want to provide it with a directory to log to. I also want to provide it with a extension, so whether I want to call it .dat, .text, .whatever. And I also want to provide a file name. What do I want the file name to be for this logger? Now I'm going to hold all this information in a configuration object. So I'm going to add a folder here, similar to how we have the trading engine server configuration. I'm going to add folder logging configuration. And in here, I'm going to go in here and I'm going to add an object called logging configuration. Alrighty, now we're going to have a lot of different loggers. So logging configuration will not only contain the information for a text logger. It will have a text logger, but that's not all it's going to contain. So it'll have text logger configuration, not a text logger configuration. So class text logger configuration. And what's this going to have? Well, we talked about what we want here. We want a string that's a directory. We want a string that's a file name. And we want a string that's a file extension. So in here, we are going to have a TextLogger configuration object. All right, awesome. Now, when we have this little configuration object, let's just say it gets passed into the constructor of a TextLogger, of a database logger, of a trace logger, of a console logger, how will that object know which settings to use, right? So if I have, for example, public class database logger configuration, then how will any object that gets a logging configuration know which settings to use? How will it know, for example, to use a database logger configuration or a text logger configuration? Well, it will know how to do that because here we will specify on the top level of the logging configuration what sort of logging configuration we're expecting. And we did that already. I believe we did that when we did the logger type. So we will use this logger type here to specify which configuration any constructor that takes in the configuration can expect to take the proper configuration value from. We'll take a look at that in a second. So this is going to have logger type here. All right. I'm going to comment this out because we're not going to be using it, but it's going to be useful for any sort of example later on. So now let's go ahead and actually implement this in the configuration file. So we're going to go to our app settings.json object, and this is what we left off at last time. I'm going to add a new section. I'm going to add a new section. That is going to map directly to the class we just created. So we could make a class called logger configuration. And that logger configuration, whoops, had a high-level item called logger type. And we're going to want to inject a text logger. Now it also had another high-level item here, text logger configuration. So let's go ahead and do that. So we're going to have text logger configuration, and we're going to have the things required in text logger configuration. So directory, file name, and extension. We're going to have directory. Let's keep it empty for now. File name, empty for now. File extension. Alrighty. Boop. And boop. Oops. We actually don't need this one. All right, so now let's give it an example. So the file extension we want is .log. The file name will be called trading engine server. And the directory, let me pull up a directory I want it to save to. I want it to save to, here. I want it to save to users, Tomer, repos, logs, trading engine. I want it to save right there. That's going to be my directory. When we're testing this, we'll see that it's saving there. Alrighty. So this is our logger configuration. It wasn't that difficult. Hopefully it's easy to understand so far. Now let's go back to our text logger. We need the configuration available in our text logger before we even implement any of these things. So we're going to have our constructor for our text logger. It's going to call our base constructor, which is a constructor of the abstract logger, which pretty much does nothing. It's still going to be called though. And what we're going to do here is we're going to actually pass in our logger configuration object. So options logger configuration. And we're going to install the package, extensions options, which we already have here as well. We have version 5. Here we also have version 5, so we're the same versions. They don't have to be the same versions, but I like it when they are. We'll save headache later down the line. And we need to be able to get logger configuration, which is under the logging. It's called logging configuration. All right, so it's under this namespace. Yes, logging configuration. So let's go ahead and say using, bam. Let's clean this up. So I like having system first, system namespace first, package namespaces later, and lastly I like to end with our internal namespaces, the ones we've created for our library. Why does this give me an issue? Login configuration is a namespace, but it's being used like a type. There we go. Alrighty. Now let's go ahead and actually set this login configuration here. So we're going to have private read-only. To avoid needing to use this namespace and avoid the error we had before, let's go ahead and change this to just logger configuration. Now we can go ahead and do this. And because this doesn't exist, where does this exist? Oh, it does exist right here. Yeah, we just changed the name. Okay, perfect. I don't like namespace qualifying everything. I just like doing the I just like the using statements. So there we go. There we go. Okay, we did it. Okay, now we're going to store this. All right, we want that on hand in our class. What we're going to do is the very first thing we're going to check is we're going to set this login configuration to our login configuration unless it's null. Now we're going to throw okie doke. Alrighty, so we have our constructor. Now we're going to go back to our dependency injection container, and we want to associate every instance of ITextLogger to this concrete implementation of TextLogger. So we're going to go here, we're going to go to host builder and type in our TextLogger right there. So every instance of ITextLogger will be associated with a concrete implementation of this TextLogger, and it's a singleton, so we will be calling the same class every single time, the same instance of a given class, anywhere that we want to have an ITextLogger injected in our code. So over here, this ITextLogger will be the one that the dependency injection container sets up here when we add this singleton object. And if we decided for whatever reason to have another class that takes in an ITextLogger, then it'll dependency inject the exact same instance of an ITextLogger because it's a singleton. All right, hopefully that's clear. Now let's go back to our TextLogger. Now let's start implementing. Let's get a little funky here. Let's get a little funky. So what we're going to do is we are first going to implement log. How are we going to log? Well, guys, in the world of trading, and I guess this probably happens everywhere else because seems like a pretty common software engineering concept, you want to be logging on a thread that isn't the thread that you call log on, that you call warning or debug or info. You want it to be a separate thread. It's a dedicated resource to writing to a file, writing to a database, etc., etc. Now, I don't like using threads because threading is an old concept. We're going to be using tasks, and a task is a unit of work, okay? A unit of long-running work. So what we are going to be doing, guys, is we are going to be adding a task that's going to be a simple while loop. And while there are objects in a queue that we need to pull from and persist a file, we are going to do so. The first thing we need is a class that is an immutable class that is going to store our relevant log information. So the log level, the module, the message, and anything else we want. We're going to call this class log information. So let's go ahead and add a class, new, what did I call it? I believe I called it log. I called it log information. I'm just trying to make sure that the code I'm writing now is consistent with the code I've written 2 hours ago. So log information. Now we're going to be using C# 9 here to create an immutable object type. And if you're not sure what a record type is, I'll put a link in the description box below. So we're not going to be using classes. We're not going to be using structs. We're going to be using something unique to C# called a record. Public record. We're on the record. And what do we want in here? Well, guys, when we're logging something, what do we want? We want the log level, of course, which is something we're passing to that log method, that log abstract method. We also want the module where we're logging from. We want the message that we're going to be logging, but we also want a couple of more things. We want the time that this log will be called at, so now, or that it'll be the time that we will be creating this log entry. We also want, per se, a thread ID, so which thread is responsible for passing on the work that we need to log to this dedicated task. So we're going to call this thread ID. And let's give it nice camel case here. Or Pascal case. I forget. Case whatever. This type of case. So whatever this case is. Let's go ahead. I think it's Pascal case. Pascal case definition. Yeah, it's Pascal case. Okay, I like Pascal case when I'm working with records. Now you're looking at this and you're like, why is there an error? Well, Visual Studio 2019 has some weird bug when it comes to record types and when you use C# 9. As you can see, we're using C# 9, and Visual Studio has some weird bug. Okay, what you have to do, you simply have to write this piece of code down here. Don't ask me why you need to do it. I found it on Stack Overflow. This is the piece of code you need to resolve this error. As you can see now, record type works perfectly fine. You can go ahead and Google the problem. You'll get the exact same solution that I just pasted here. So go ahead and paste this right below where you created the record. Okay. Now what we're going to do, guys, we want to hand off the work to log to our task. Whether that task is a dedicated thread or it's a thread from the thread pool, that's not important. Task abstracts all that worry away. So what we're going to do, guys, is we are going to pass it through a queue. Now I'm going to use something called a buffer block. Okay, a buffer block. I really like buffer blocks. They're easy to use. We're going to buffer block. And it's going to be of type log information. We'll call it log queue. And where is buffer block? Where is buffer block? Buffer block is in systems.threading.dataflow, which I need to find and install. We need to import this package. Okay, and this is imported, but it's still part of system, so let's just do that. Now we have access to buffer block. Now, how are we going to use buffer block to log? Well, buffer block is a thread, you can think of it as a Threadsafe queue that has an asynchronous API. And an asynchronous API is going to be useful for our task because tasks can take advantage of asynchronicity. So what we're going to do here, guys, when we log is we're going to just simply call logqueue.post. Post is a synchronous post into this buffer block, into the underlying queue behind this buffer block. Now we're going to create this new log information. So log level, we're going to forward it. Module, we're going to forward it. Message, we're going to forward it. Time, we can just call datetime.now. Thread ID, we can do thread. We're going to need to use system.threading. So right there, we're going to call thread. Current thread, manage thread ID. And for thread name, we're going to do something similar. Thread, current thread, name. And that is simply going to post the log that we want to log with the log level we want to log it in, and the managed thread ID that actually calls post, and the thread name. We're going to all pass that down into our queue. Now our long-running task responsible for actually logging to a file in our TextLogger will receive this, will pop it off the queue asynchronously, which we'll see in a second, and it'll then focus on formatting it into a single string and writing it to a file. Let's take a look at that. Okay, that is going to be, we're going to call that private static void LogAsync, right? What's it going to need to take in? Well, it's going to need to take in a string that represents the file path we want to log to. File path. What else is it going to need? Above and beyond a string, it is also going to need to take in it is going to need to take in, I guess, this backing queue. So we're going to need to take in here buffer block. Our queue, because it's going to need to pop off an item from this queue. So queue. Let's just call it log queue. And we're also going to need to take in a cancellation token. Why do I need a cancellation token, Coding Jesus? Well, this is running asynchronously somewhere. I don't know where it's running. It's not my responsibility to know, but it's going to be running asynchronously somewhere. We want this task to finish gracefully. It's going to be a long-running task, but we want it to eventually finish gracefully. And we're going to get it to finish gracefully by canceling this task, which you'll see in a second. The first thing I'm going to do is I'm going to open up a file stream, because we're going to be writing to a file in this LogAsync method, file stream. We're going to be opening up a file stream using system.io, so I added system.io up here. We're going to be passing in our file path, and some permissions here. The first permission we want is we want to file mode. We're going to want to create a new file every time. Okay. We're also going to want file access or file mode first. We're going to be writing. So we want to do, no, not file mode, file access. I said it was right the first time, file access. So many access, mode, permission, etc. We're going to be writing. Now here we also want file share. So we want other people to be able to read this file while we're writing. So we're going to allow for reading permissions to other parties that would like to read from this file. So read. Okay, now we have our file stream. Now we want to write this. This is a text logger. We want to write it to text. So we're going to be also using a stream writer to write this down as a to persist it into the file stream as text. So using var stream writer equals new stream writer. This looks like SR stream reader. We'll just do stream writer. File stream. Okie doke. Now we have our stream writer and our file stream. I'm calling using because I want to dispose of this object, because this object inherits from my disposable. I want to dispose of it at the end of the scope. Now you're looking at this function and you're saying, coding Jesus, the end of the scope is one line away. This is going to be disposed of immediately. That's not true, because like I said, guys, this is a long-running task. And how do we get a task to run for a very long time? A while loop. So we're going to first wrap it in a try-catch. And we're going to say, while true, go ahead and write to a file. So what we're going to say is the log item equals, we're going to asynchronously wait on our queue here. So log queue, receive async. We're going to pass in a token here. Okay. We are then going to get our formatted message. So formatted message. Excuse me. And we're just going to say format log information. Format log item. We're going to pass in a log item. And then all we're going to do is simply write that to the file. Write async. We're going to pass in a string. Formatted message. And there we go. We wrote to a file, and we're doing so in a very long running task. Now this can't return void. It needs to return a task. And I want it to be async. A long running task in which we are able to await the contents of the task in the method. Okie doke. And now I'm actually going to implement this as well. Format log item. Private static string, format log item. And guys, this is going to be how our log entries are going to be formatted. Now, usually, I guess in software engineering in general, or kind of the way that I'm used to doing it, is the first item we want to see in a log entry is the time. When was this log entry emitted? So what we're going to do here is we're going to return a string. The first item we want in here is we want time. So we're going to put it in these brackets. We're going to do a log item. Now, and we want to format the time. So let's just do, the right time formatting is hour, minute, second, 1, 2, 3, 4, 5, 6, 7. So we can get tick precision. And then let's just do year, month, day. Let's log it that way. Do we want it that way, or maybe? Let's do it the other way around. Let's do it like this. I like this a little better. The next thing I want to log, guys, here is I want to log the information related to the thread that called debug, or called information, or called warning, or called error, that said we want to log. So that called those methods on our text logger. So I'm going to have here another field. I'm just going to say the first thing is going to be log item, the name of the thread. Okay, and I also want to have its ID right beside it. So we're going to also have log item dot thread ID, and we want to show 3 decimal place or 3 digits, right? And we want to do this. We want to pad this, so we want to have padding. We can pad to the 30 white spaces to the left. Alrighty, now let's go ahead, and the next thing we want to log is our log level. So how important is this? What's the priority? So log item dot log level, and the last thing we want probably is the message. So log item dot message. And that's the format that we're going to be formatting our text log entries in. Very simple, very easy to understand, and very easy to work with. All right, guys. Now let's actually run our LogAsync, and we're going to be running it in the constructor. So we're going to go ahead and do task.run. We're going to be passing in an action, which is a lambda, and that lambda is going to be LogAsync. We're going to be passing in a file path, so let's just have a temporary variable called string file path for now. We're also going to be passing in our log queue, so our log queue, and we're going to be passing in a token, a cancellation token. So let's go ahead and add our cancellation token to the bottom here. So private read-only cancellation token. Cancellation token source. Token source. Okie doke. And let's go ahead and then pass in this token source's token here. So the token source controls cancellation and disposition of the token source and the token, and it contains the token object inside of it. So we're going to go ahead and do that. And also what we want to do, guys, is now we want to actually go ahead and create the file path that we need to pass in here, because now it's just empty, it's just junk. So let's go ahead and do that. So the first thing we want to do, guys, is create the log directory that's specified in this logger configuration, if it doesn't exist. So what we're going to do, guys, we're going to do something like this. So we are going to say, we're going to have our log directory, and it's going to be, let's combine the TextLogger configuration directory, and I also want to combine this with a date. So how I want my schema to look in terms of my directory is, I want to have my directory, and under where I specify I want to log, I'm going to have another directory that's the date. So we will be date partitioning our logs. So we will have something like var now equals datetime.now. We were going to have now, year, month, date. What this does is it says I only want the year, the month, and the date out of this date object, which obviously contains more than the year, the month, and the date. It contains the hour, the minute, the seconds, etc. So we're going to create this log directory path. Okay. The next thing we're also going to do is we're going to create the log name. So string base log name. And that is going to be the combination, so path.combine between our TextLogger configurations file name and our TextLogger configurations file extension. Okie doke. Awesome. Now we're going to combine both our directory and our base log name to create our full file path. So we will do something like path.combine log directory base log name. And there we go. We've created the file path that we want to actually write to. The file and the file path that we'd like to write to. Okay, now I'm missing something here. I took in this logger configuration, but I'm not sure if my logger configuration is configured for text logging, for database logging, for trace logging, etc. I don't want to allow a user to take in a logger configuration configured for database in my TextLogger class. It doesn't make sense. So what I'm going to do here is I'm going to add another check. So if logging configuration logger type does not equal logger type.text, throw new invalid operation exception, name of TextLogger doesn't match logger type of logging configuration logger type. Easy enough to understand. Alrighty, guys, so we have our long-running task here running in the background. We have this overridden previously abstract log method, which determines how exactly we want to actually process the log level module and message passed to this method. So what we want to do with it, here we're saying we want to pass it to a queue and let our long-running task simply persist it to a file. And we have our dispose method which we haven't implemented. Why is this dispose method important? Well, guys, we have this long-running task, and we don't want it to run forever. All right, we don't want this long-running task to run forever. We want to eventually cancel this task. So in our dispose method, we will do that. But we were actually going to implement something called the dispose pattern. We were not going to call token source.cancel here. what we are going to do, guys, is we are going to do this. We are going to create another dispose method. And this dispose method is going to take in a Boolean value. So we're going to have an override of dispose. It's going to be protected, virtual void dispose, and it will be bool disposing. All right. I'm going to put a link to this dispose pattern in the description box below so you'll understand why I'm doing this. So what I'm going to do is I'm going to say garbage collector dot suppress finalize this. So what I'm saying here, guys, is, let me first write it and I'll explain. So I'm going to say if we've already disposed of this object, so private bool disposed. It's going to start off as false because the object is not disposed when it's created. If disposed, I want to return. Otherwise, I want to set disposed to true. Okay? What I'm going to do, guys, here is I'm going to say if we're disposing, when we call dispose directly, then we want to get rid of managed resources. Everything that's available to us that we can call dispose on, or we can actually dispose, that we can guarantee has not been collected by the garbage collector. So we are going to go ahead and say token source, we want to cancel, and token source, we want to dispose of our token source. All right. Anything down here is disposing of unmanaged resources. So get rid of unmanaged resources. Coding Jesus, what's an unmanaged resource? It is a database connection. It is a file stream. It is anything that requires you to dispose of something external to this application, like a database connection. All right. Token cancellation source, it's something we create here, and it doesn't involve speaking to some other service somewhere else. It's not unmanaged in that sense. And I'll include a link to what an unmanaged resource is in the description box below. Now, what I'll also do, guys, is if we are calling dispose from dispose, then we will be passing disposing in as true. We will get rid of our managed resources. But if if this object goes out of scope, this TextLogger goes out of scope and it's no longer used, and we didn't call dispose on it for whatever reason, the garbage collector will pick it up and it will put it in its finalizer queue. I will put in the link in the description box what a finalizer is. I won't be explaining it now, but kind of think of it as a destructor. It's kind of a destructor, but it really isn't. So we will have here TextLogger. So this kind of looks like C++. Think of this as a destructor. And what we're going to say is we're going to say destroy everything that is available to be destroyed and has not been garbage collected. So dispose false. Now what's going to happen when I call dispose false? It's going to go in here, and what it's going to see is we're not going to be getting rid of managed resources. The finalizer can't depend on these being here anymore because the garbage collector may have collected token source by the time this is called, by the time the finalizer calls this. It's possible that token source will be null, so we can't call cancel on the token source. We can only now get rid of unmanaged resources, like closing a database connection, etc. All right, so that's what we have here for our disposition here. Now I'm also going to wrap this in a lock, just for good measure. So I will say private read-only object lock equals new lock, a new object, and I will say just in case we have some other initialization code that might be running on some separate thread, for example in LogAsync, that checks disposed. Okay, that doesn't happen currently, but just in case. Alrighty, guys, we are done with our TextLogger. We finished writing our TextLogger. So now we can actually go ahead and see this TextLogger in action. So let's go ahead and go in here into our server, and let's replace this logger. We don't have log information anymore. We just have dot information. We're going to pass in our module, which will be name of trading engine server. And the message we're going to say is starting trading engine. Now here, we're going to have same thing, name of trading engine server, stopping trading engine. All right, guys, now let's see this in action. But hey, I forgot something. I created this directory, but if this directory doesn't exist, we need to create it. So I'm going to call directory.create. Now, if this directory already exists, this is a no-op, nothing happens, it's safe. But if it doesn't exist, then it'll create one. So there's no need to check, for example, like directory exists. There's no need to do that first. You can just plainly call create directory. Alrighty. Let's call it. To avoid clutter, let's just call it down here. Alrighty. I think we have everything that we need. to now see this logging in action. So let's go ahead and fill this out. So I filled this out with where I want it to be logging, what I want the file name to be called, and .log. Now what I also want, guys, which I didn't mention yet, is I want to be able to distinguish various files. So for example, here, I'm going to call my file currently trading engine server, and it's going to have the extension .log. Now if I run this application 100 times, I'm only going to have one log file. They're going to continuously override each other. I don't want that. I want, if I run this application 100 times, I want under today's folder in this path, I want to have trading engine server 100 times, one for each instance of the time that I've ran this trading engine server. So what I will do here is for this file name, I'm going to change this file name to append some unique information. I'm going to append the date that this file was theoretically created. Okay, so what I'm going to do is I'm going to say this. I am going to say that I'm going to call this file. This is going to be the file name. That's going to be the first thing that it's going to be. That's going to be here. But I will also say I want the date. So I want now. Give me the hour, minute, second. I want that. And just for simplicity's sake, let's just call this unique base. Let's call it unique log name. So every time this will be called, because I'm not going to open and close this application within a second, we're going to have a different log file name. So the first one, if I run this application for an hour at 12 a.m., it'll be, log file, whatever name, whatever, 12 a.m. And if I run it at 1 a.m., it'll be 1 a.m., whatever. Okay, we'll see that in a second. I'd rather show you than talk through it. Okay. Awesome. Okay, let's go ahead and run this application. First, let's see if it builds. So, we're missing something. We need to add the dependency injection of actually creating our logger configuration. So let's go ahead and copy this, and we're going to say logger configuration, which is under a new namespace. So using trading engine logging configuration. We're just going to do this. Okay, cool. Now I think we're good to go. So let's go ahead and start this. Let's put a breakpoint right here. Okay. Start trading engine. Now is the moment of truth. Builds. Okay, what are we getting here? An exception. Null object exception. Directory. Ooh, our directory is null. Why is that the case? Why is our directory null? Oh, our TextLogger configuration is null. That's a no-no. That probably means that in our app settings file, we have a spelling mistake. Directory. TextLogger configuration. Let's go ahead. This is part of the process of learning debugging, so let's go ahead and logger configuration. TextLogger configuration. TextLogger. Same thing. Logger type. This is called logger type. Let's just get rid of this. Logger configuration. Oh, login configuration. Change it to logger configuration. Awesome. Okay, now this should work. So let's go ahead and run this. Awesome. So I'm going to go ahead and continue. And guess what, guys? Guess what? Our trading engine server is running, and our TextLogger is also working. How do I know that? Well, let's take a look right here. This is where I want to save it. Tomer, source, repos, logs, trading engine. This is the folder, the directory, the date that that this application's running. We're going to go in here, and we have this folder is empty. Interesting. So now let's go ahead and debug some more. So I'm going to close this, and let's go ahead and debug some more. So let's see what happens. If I go here, and I go to information, let's walk through this. So I'm going to go in here. Yep. Post to the queue. All right. I want to put my breakpoint right here. Ooh, I think I know what the problem is. I think because the stream writer isn't being flushed, there isn't a good enough amount of information here. So let's try on auto flush in the stream writer. Receive async log item. Okay. I think that's the issue. Post. All right, let's give it another run. Okay. This breakpoint should have been hit. Let's go ahead and check what's going on here. Logs, trading engine. That auto flush did not. Let's see here. What happens here? Okay, file path. Oh. That's weird. That shouldn't be happening. Oh yes, because I called the wrong method. Okay, so I said path.combine with the extension. What it should be is path.extension, change extension. That should be it. Okay. Path.change extension. Okay. Yeah, that's where we want to be writing it to. As you can see, it's 12 a.m. right now, so make sure to give me a like and a thumbs up. Perfect. Perfect, perfect, perfect. Okay, now let's go ahead and check out that file. Bam, we got it. Okay, we got it, ladies and gentlemen. So this is our file that we're writing to, and let's go ahead and take a look at it. Open the file, and this is our log file. So as you can see, I have the current time, so this is the time that the actual log entry was written, or log was called, so log information was called, or information rather, not log information, whether information was called, which is right over here, information, and we can see that the thread has no name, it's a nameless thread, and the log level is information, and this is our log entry, starting trading engine. There we have it, guys. That is our logging facility so far for TextLogger. That's really all the logging I think we're going to need, just TextLogger, but this is extendable. You can have a database logger, a trace logger, any logger that you really want. So thanks for staying with me throughout the debugging. That's just a natural part of software engineering. If you like this video, make sure to give me a thumbs up, share, subscribe. I mean, it's 12:30 a.m. guys right now, and I'm making this video because I really enjoy this series and I want you guys to learn a lot. So if you like it, just make sure to give me a thumbs up. I have a Patreon link in the description box below. I have a Calendly link if you want to speak to me one-on-one for whatever reason. I have paid consulting sessions that I mentor, etc. I do resume reviews as well. And yeah, just in general, make sure to check out the links in the description box and become a channel member if you did enjoy this video. Channel membership comes with a lot of cool perks, but if you don't want to become a channel member, that's fine. All my content's free anyways. Thanks for watching, guys. Cheers.